All right, we'll get started. So thanks so much for joining us. Today in the webinar, what we're gonna actually be doing is doing a live code demo. So I'll review just a couple high-level concepts from our last webinar. But for those of you who aren't comfortable getting into the code a little bit, this webinar may be a little less comfortable than our last one. So I encourage you to go ahead and view the last webinar, and in case you don't stick around to the very end, our next webinar will be on coding Fluree smart functions and how to set up smart functions, how to think about smart functions. So if that's a topic that interests you, then we'd love to see you the next time we do our webinar. So in the interest of getting things set up or started while I go over that initial overview, what I'm going to do first is we're going to just start everything here from scratch. In fact, just let me make sure. We are going to first start up a clean instance of Fluree. So I'm just running Fluree. Again, Fluree executes as a Java app, a Java jar file when you download it. So we're just going to get it started. And we have a clean setup at this point with Fluree. So it's going to get started. And you see here it recognizes that there's no data, no sort of established network for it to connect to. So it's going to create a basic installation here for us. And the other thing, because it takes a little while, ultimately, we are going to end up creating a React application. So we're going to get some data into Fluree, we're going to configure a schema, and we're going to build a front end that's actually pulling that data. So if any of you have tried to build an application that's leveraging data from a blockchain, this is going to just seem immensely simple for you. The reason is, of course, because most blockchains were never designed to have to be queryable, to power an application. So you still need to develop really a traditional application stack, and then you need to develop some sort of integration that's trying to get the information from the blockchain over to your app stack and do everything essentially twice, in a blockchain way and in an app way. And Fluree is able to really merge all of those aspects together. So what we are going to do, and let me actually get the command in my clipboard, we're going to create a React app. I'm going to stub it out. So anyone who is used to creating React applications will be very familiar with what I'm going to do here, but I'm going to use the create React app stub. And we'll just get it started. So this is basically going to set up a vanilla React application for me to then start building Fluree stuff into. And again, this will take a little bit of time. So we'll come back to that while it's setting up our React app. So Fluree, as a quick reminder, Fluree is really designed to be a data platform for Web3 applications. So this is the interconnected machine-to-machine web. We'll actually show a query at the end where we're joining data in the database that we just built right now with data sitting in Wikidata, which also participates in Web3. Wikidata, for those not familiar, it's really the data component, the big global database component to Wikipedia. Wikipedia, of course, a little bit more designed for humans. Wikidata, a little bit more designed for machines to get access to this globally updated information. Wikidata, like Fluree, participates in this Web3. And the goal here is that we are able to connect different data sources without having to try to move data all the time to be able to join data or get more use out of it. So traditionally, we would use things like data lakes, data warehouse. Of course, if you've been paying attention to the security news lately, you'll see that a lot of our data breaches are a result of us getting data out of their protected sources and into these common data warehouses, and then not having those data warehouses properly secured. So our goal here is to leave the data in its sources, but be able to connect it. And one important thing about a Web3 based application, and in our case, it's a semantic web graph style application, is that even if you're building a sort of Web 1 or Web 2 type of application, you can use Fluree or Web3 technologies to power that. So everything sort of in this chart here is kind of backwards compatible. So what we're going to show today is actually this exact screen. I will, as far as the architecture stack that we're going to go through. So what I just did as we were beginning is I started the bottom layer, the RDF-based immutable blockchain ledger. So we fired up a brand new instance of Fluree, and it has created and is now sitting there waiting for requests. We are going to connect to Fluree via, well, we'll use a couple things. GraphQL, we'll also use FlurryQL, which is JSON-based. And we're going to build a front-end React application. And again, our viewpoint is that the approach is more of a data-driven approach. So as long as you secure the data properly and you set up your data properly, it should be trivial to create applications, redo applications that all leverage that data. Hopefully you'll get a sense of that as we continue. The parts that we're not going to show today, but just to remind you they're available, is that if you are trying to serve an immense amount of traffic, you can set up what we call our Fluree Edge servers. These are sort of like content delivery network servers. You can deploy them in any data center anywhere in the world, and essentially they're getting a live feed from the blockchain of changes. So unlike a content delivery network that you might be used to, there's no need to like have expiration times or invalidate caches, because Fluree is just going to automatically keep everything in real time up to date. But this is really what allows this blockchain component to scale to literally billions of queries a second. So this edge network can scale linearly. And of course, you can use the same tools that either talk to a server or to a load balancer that's balancing between multiple servers in an edge network, or more in development, we're just going to connect directly to the blockchain servers itself to do this. And lastly, Fluree enables you to participate in a decentralized network. So one or multiple databases can actually have validation from multiple organizations, which means really for the first time, multiple companies can actually jointly own a database, because all of them will get a vote as far as the validation and everything that happens. So in order to do that, you would set up an exchange or consortium. And because Fluree is really good about connecting data sources, it means that your applications can actually view even multiple Fluree databases controlled by multiple entities as though they're basically a single database. So there's a lot of flexibility in there, and this again gets into the core of some of these Web3 standards that we talked about. So without further ado, I should be able to hide this, and yes, we have our app loaded up, our basic React application. So here's the basic React application, and let's actually come in here and run npm run start. And we should get, again, if anyone's used Create React App before, you've seen this. So we have a basic React application created and running that we can now code and do several things with. So let me just move this a little over to the side. So we started a brand new Fluree instance, as I mentioned. In fact, it should be running right over here. And what we haven't done yet is we haven't set up a schema or anything to work on this or to get data. So we need to start there. So this particular example, we're going to set up just in the interest of time, really, a very, very simple schema. And that schema is going to be an invoice application. So it allows multiple companies to create invoices. And the invoices just have a few simple attributes, just so we can get some stuff on the screen and start showing that. So I'll jump over here to the schema. We create all of this from scratch, but I'm going to use a little bit of cutting and pasting to not only save time, but avoid me having any typos. But our invoice schema is going to be really simple, as I mentioned. So we're going to have an invoice collection in Fluree. And again, Fluree is a RDF, graph style semantic database. But when I say collection, the easiest thing, if you're used to relational databases, to have the analogy is a table. You know, Fluree doesn't really force data to sit inside of a table. It has more flexibility than that. But effectively, this is like an invoice table that we're going to create. And the table is just going to have a few things. It's going to have an ID for the invoice, and we're going to set that up as being unique, and it's just going to be a string. It's going to have a buyer and a seller. The buyer is going to be a reference to an organization. And again, unlike a document style database, Fluree is a full ACID compliant graph style database. So you can create these relationships and query data multiple ways. I'll actually show some of this as we go through it. We have items in the invoice, and we set this up as multi-cardinality, meaning there can be more than one item in an invoice. And we just set this up as this very special type of data type inside of Fluree called a tag. And tags are just kind of like tags. They'll auto-generate. They don't already have to be in the system, but they're great ways of connecting different types of data together with a common tag. So they're very, very convenient to use for various reasons, especially with things like enum values, et cetera. And then we'll throw in a cost for the invoice, which we'll just store as an integer. And then again, this buyer and seller up here, both connected into the organization. And so we need to create an organization collection, or again, table. And the organization is just going to have two predicates on it. It's going to have a name, which again is going to be a unique string, and then a reference to multiple employees. And the employees are going to use an internal collection type within Fluree called underscore user. So when you first create a Fluree ledger or database, it creates a series of sort of system level collections that it's going to use for things like authentication and other related items. One of those is user. So you can create your own user collection if you want. I'm just going to use the one that really comes out of the box with Fluree. So we should be able to come over to our Fluree UI. Let me see if I can. There we go. Okay. And so because we have Fluree running, now I'm able to access this little admin UI we package up with Fluree. Again, most of the time your apps are talking with Fluree directly, but this gives you an opportunity, of course, of being able to just issue queries from an admin UI, understand what's going on. So we are going to add example invoice. We're going to go ahead and create that ledger. And now it's in the system, and we're going to go ahead and select it so that we can start issuing transactions against it. So I'm going to use Fluree QL here. And the first thing I'm going to do is I need to create this schema that's going to house our data. And so the same way you could create a schema in Fluree is the same way you submit any sort of data transaction. In fact, the schema, Fluree Smart Functions, everything that runs Fluree is actually just data inside of Fluree, which means it enjoys all the same protections and security that any other piece of data that you have in Fluree. But I'll just go ahead and copy this transaction. And you'll see here we're going to create, again, the invoice collection, and here's the invoice ID. We're going to say this is a string, and it is unique, invoice buyer, etc. So we'll go ahead and submit that. And I'll turn off this history so we can see the results. But we see the results over here. And one of the things that we've done is that anytime you create a new, what's called in the RDF space, a subject, but it's like an object or an entity. Anytime you create a new subject, we create a permanent integer identifier that will always exist. It will never ever change. And when you create new things, we allow you to give them temporary identifiers so that when you get the results back, you can turn around if you needed to issue a query against something, you'd have the data to do that. So this is one of the pieces that we're going to get back in the result, is based on all of the items that we created over here, what are the permanent identifiers they were assigned. I also see that we're now at block 2 in the blockchain. So block 1 was really where Fluree created that initial transaction and created those initial system tables that I talked about before. We have a new hash for this block. And an important thing is that if you give this hash to anybody, using that hash, they can make you prove the integrity of your entire system. They can you can prove that your data has never ever been tampered with at any point in the future. So one thing that I think is surprising to people is that you can get this immense integrity of data where you have proof of everything without having to run Fluree decentralized. So decentralized, of course, will add a little bit of extra trust because you have other parties validating each of the transactions. But if all you want to do is really prove that data has never ever been tampered with, you can simply supply this hash to anything external. And there is only one way to end up recreating this hash, and that is to have the identical data within Fluree in the future. So you can get these characteristics even just running Fluree locally. We record the moment in time. Importantly, here we're outputting the amount of fuel. So if anyone's used like Ethereum, you're used to the concept of gas. We use fuel in Fluree. So this is basically the amount of work internally that Fluree took to process this transaction. We always have every transaction signed. I'm in dev mode, so it's signing all my transactions on my behalf. This is what allows Fluree to prove who changed every piece of data in the system throughout history. And of course, here is what we call our flakes. And this is the Worldwide Web Consortium RDF standard is everything we have flakes based off of. So in an RDF standard, there's subject, predicate, object, and here's our subject, here's our predicate, and here's our object. One thing for our predicate, which is basically the attribute names, we're using integers here. We use that just to make it more efficient in storage. But we also then allow you to actually change. If you're doing schema updates or other things like that, it gives you a lot of flexibility. So in this case, this predicate will end up mapping to something like name, type, or unique, or any of these sort of keys in our JSON map. And it'll allow us to re-alias things. So it's kind of like a domain name service in a way, but it's actually for attribute names that can be used in Fluree. But here's essentially the change state of the entire ledger or the entire system. And again, Fluree is going to take these changes, it's going to broadcast them out, it's going to get approval, it is going to, if it has approval, it's going to broadcast them out to the edge network if you're running those. And effectively, it is just the delta in the system itself, the ledger. And we take these flakes. Your apps can actually listen to this and do pattern matching and trigger, you know, a Twitter post or an email based on data changing in the system. We, of course, in Fluree take these flakes and turn it into a time-traveling graph database, which is really what allows us to power our apps on it. So, okay, we got our schema in. So let's get a little bit of data in here now. So I've got some sample data. And right before I put this in, I'll jump actually over to, let me expand this so I can see my menu options here, to the schema. If we want to see what's in the system or what the schema looks like, right within this UI, we have the Schema Explorer. And this is really just using our out-of-the-box GraphQL interfaces. But recall here that we created a invoice and an org just a minute ago in our schema. And here's, of course, the values, and I can see that they, you know, the seller and the buyer and the org point over to the org collection, etc. So if we ever need to check on our schema, we have the data there. Well, let's go ahead and populate some data in now that we have the schema. And what I'm going to do is I'm going to create a couple organizations. I'm going to create a Fluree, Nuco, and Deloitte. I'm going to use Deloitte actually later because I'm going to do some join with Wikidata and some information that's there about Deloitte as an organization. So I put in a real company in that particular case. In Fluree, when you create transactions and you need to create references or effectively joins between different things, there's three ways of doing it. One is via what we're doing here, which is temp IDs. So like I don't have I'm creating Fluree and I'm trying to put two employees in it, Scott and Brian, but those employees don't yet even exist in Fluree. I actually see I'm creating them here. And what I've used is I've used a temporary ID to be able to reference them from other transactions. And again, as an ACID compliant database, if any part of this transaction failed for whatever reason, for example, if there was already a Brian in the system, because if you recall when we created the schema, or actually this is a system schema, but username is a unique attribute. If there's another Brian in the system, this transaction will fail because it's duplicating something that's already there. It will fail the entire transaction. It won't fail just part of it. The other ways to reference employees in this case is I could reference it via that permanent identifier if I happen to have access to it, or I can use any unique attribute in Fluree. So, you know, just use a little scratch pad. These would be the three ways. Temp ID. Second way would be, you know, the permanent identifier that gets assigned if we knew it. And then the third way would be any unique attribute we define. So if I had like person email as a unique identifier, that would be yet another way of uniquely referring to a individual in this case. So those are three valid ways. You use them in, depending on your particular circumstance. In this case, we're using temp IDs. So we'll go ahead and transact this data in here. And what I see coming back for each of these temp IDs I use is the permanent identifier that will always exist now in the system. Of course, we're now at block 3. We have yet a new hash that again can prove the entire state and history of the Fluree system, some fuel, and of course here is all of the deltas, again, of the database or the system that we've created. So we've got some sample data in there, we've got some organization, some users, we of course had our schema in there first, and just so we can get something else in there that we can build our app that's going to display invoices, let's go ahead and add an invoice. So I'll do yet one more transaction. We're just going to use, again, a temp ID. We're not making it unique here because we don't really care about it. Here's the unique identifier that we're calling this invoice. Again, Fluree will reject this transaction if an invoice is already in there with that identifier because we mark this as being unique. Here we're going to refer to the buyer, and we're using that last form that I showed before. So here we're using org name NewCo and org name Fluree in the case of the seller is a way of uniquely referencing those items that we already know are inside of Fluree. But we don't know the unique identifier. In fact, here's the unique identifier right here from the results of our last transaction. So I could alternately use that unique identifier, but instead I'm going to use NewCo here because it's easier to deal with in most applications. And I'm going to sell these two items. So we'll go ahead and transact that. And again, now we're at block 4, and we've got our results and our information in there. So let's issue a simple query and get out. Let me grab a query so I don't. So what I'm going to do is I'm going to basically select star from invoice, and I'm going to follow these references. In fact, first I won't follow them and show you what I'm doing here. So I'll do select star from invoice. So we just created this invoice 1, 2, 3, and I can see that we have a buyer and a seller, but I don't see the details of that buyer and seller. Again, it's referencing some other subject. And I just have the identifier of the subject here, but not the details. So as a graph database, we can simply crawl that information. So what I do is I basically say, crawl that relationship, the buyer or the seller, and basically a query within a query, select star from that. So if I reissue this query, I'll start to now see the details there. If instead of star, for example, I just wanted the name, I could just say, you know, just give me the name for the buyer, but for the seller, get me all the other data. And again, I can keep following these relationships. You see here that this now refers to employees. If I wanted to pull out the employee's name, I could. I'll demonstrate this a little bit later, but all relationships in Fluree always go both ways. So while I'm following the relationships sort of downward here, I could always start with an employee, get up to a company, and then also get to from there to the invoices that were perhaps issued by them or for them. So every relationship always goes all ways. But here's a simple result for query data. And now what I want to do is take this and let's get this into our React application that we started to build. So we'll do that here next. So here's our React app. So how do we start getting Flurry into this now, and those data results into it? Slide this over a little, and here's our app. And if I just start changing things, it's going to auto reload for me here on the right. So every time I make a change on the left, I'll see some new data on the right. So one of the things I'm going to do, and again, I'm going to copy and paste a little bit here just to help me out, is I'm going to use the Fluree React library. Now the Fluree React library is not yet published. So this will be published within, really, we expect by the end of next week. So this is a little bit of a preview here of Fluree React, but it's a nice wrapper around the JavaScript version of Flurry that knows how to interact directly with React. And we'll see some of that magic that happens here in a minute. So again, Flurry, we have a packaged version in JavaScript. You can actually literally embed directly into any web app or mobile app, and it will communicate back to the edge networks and the rest of the network and just stay up to date. So effectively, you have a database running in memory right with your JavaScript application, and that's actually what we're using here. So we're going to import a few different items from the Flurry React library. And then the first thing we're going to do is use this React Connect here to connect to this ledger that we're running. I'm just running it locally. And here is the ledger that we want to connect to in this case. So we'll just go ahead and save this. We're not going to see any data or anything yet. But now when this page loads, it's actually loading up a FlurryDB instance in JavaScript inside of my app. And it's connecting that FlurryDB instance to a running ledger, which I'm running on my laptop. So let's create some UI components that are going to display invoices. And I'll do a little copying and pasting here as well, just to help me out. So I'm creating two simple UI components, one called invoice, which is going to render each invoice. In here, I'm rendering out invoice ID, buyer, seller, and items. And I just have some static data here, just so we can see this happening in the UI once I put this in and save it. And then all invoices, which is going to be a wrapper for each invoice. So it's going to get out a list of every invoice in the system and then end up rendering each of these invoices directly. And so this is just going to paste out a table here and some header items for the table, and then of course our invoice items, which are going to end up displaying each of these UI components. So I've got to do a couple things. One is I need to start rendering out this data. So instead of all this React image and stuff that I have here, let's instead render out all invoices. In fact, I need to kind of add a fake item here so my sample data renders. But here is now my invoice data rendering. So here's my headers, here's the fake item basically that I put in there. And now what we need to do is we've got our rendering happening. Let's turn this into live data. And I'm gonna, just to help us see here, I'm gonna add a couple table styles here. This isn't about trying to make this pretty, but at least a little bit more usable, add some CSS styles so there, it breaks up our table a little bit better. Okay, so now we need to get Flurry data in there. So the first thing we need to do is we need to wrap our application in what we call the Flurry Provider. And this is going to pass the connection to the ledger that we created right here. It's going to make this available for all of these React components. So you can have a bunch of Flurry providers if you want, each connecting even to different ledgers, but when you wrap your React application with them, it's going to make that information available to everything inside of that tree. So because we're doing all of this at a high level or only one app, we'll add Flurry Provider here. So we're just going to wrap our application in Flurry Provider. And again, Flurry Provider's purpose is to make the connection available. So we're actually just going to use pass for the connection attribute, this variable, which again, this is right here. So this is just creating that connection and passing that connection to our our UI components. So we'll go ahead and save that. So now we have Fluree available to the whole React application through that connection we created. We've got some sample data being created, but now I want to start getting this data inside of Fluree so I can see what's going on. So let's jump back over to this query that we issued. I'll just say star here. So this is the data I now want to get into my UI. So this query looks good, but what I want to do is, instead of modifying the existing React components, because I don't want React to have to know anything about Fluree. This gives me great flexibility. I can use all the React testing libraries, everything out there. What I want is Fluree to just inject query result data directly into the component. And it's going to do this through this data variable. So we want the query results we have over here to be injected into this component, into this data variable. And how I can do that without having to modify this component at all, which is very nice, clean, and pure, is I can create a new component that wraps that component with a Fluree query. So let's call this all invoices Fluree, because we're going to make sure we have that Fluree data. And what we do is we wrap it in this Fluree QL component, which again came from the React library. So we wrap a query in the first part, and then any component in the second part. So we know the component we want to wrap is this all invoices component. So we'll put that there. And the query we want to inject in there is this one over here. So we'll just do that. And now what we have is we have a new component that wraps the query results around this existing component and will inject the results directly into this data variable. So we'll go ahead and save that. And we'll jump over here. We're still not going to really see anything because we're not pulling out the new data. The first thing I want to do is make sure that instead of rendering out this component, I now want to render out this component in my app. So I'm going to swap out all invoices for all invoices Fluree. And the other thing is we just had this sample data here that we initially set up, and we want to start getting the data in this nested result set. So again, I'll cheat a little bit over here, but I will just copy and replace these stub data. Oops. With now this invoice will come in with real data, and I want to get out the invoice ID, the buyer, and then the org name. And you can see here, here's invoice buyer, here's org name. So that's the data I want to pull out, and I want to end up displaying in my React component. So we'll jump over here, and we'll do a save. And lo and behold, I'm now getting data directly out of Fluree. So it was that easy. I just wrapped the Fluree component around my existing React component, and now it's just injecting data results right in there for me to see. So that's pretty cool, makes it pretty easy. Again, if you've tried to do any of this with any other blockchain-based application, you know that getting to this point is usually something that happens after a few weeks. So let's move this over here so we can see what else happens. Now, our Fluree React component, as I mentioned, it understands React. And actually, as each of these React components are being rendered with queries, Fluree ends up taking an inventory of which UI component is using which query, and therefore can automatically know when data gets updated, which UI components might be affected by that. And again, you can have hundreds or even millions of users running your application that are all sitting there running a local version of Fluree that's just listening for these sorts of changes. So if I come back to the transaction and we created this invoice initially, let's create another invoice called ABC for the ID. And this one, the buyer will be Fluree, the seller will be Newco, and the items will be a tablet and a phone. Anywhere that this could exist, this transaction will get signed, sent to any of the nodes running the transactors. It will propagate them. And once all the transactors agree that all the rules, the smart functions, which again, we're not really going to cover here, but we have another webinar where we'll cover smart functions that allow you to control permissions, who can change what, more specific attributes of what data has to look like. But assuming it passes all those rules, we're going to create a new block from this transaction. So we'll go ahead and submit that. It goes through all those rules, and I see my UI on the left updates for me automatically, which is pretty cool. And so any UI or any app that I am building, I can just basically wrap queries around it, not worry about things having to go across the wire to get new data, because the database is actually running locally. In fact, all of these queries are actually just hitting an already cached version of the data. So each time it renders, there's no API request going on for getting this new set of information. And all of my apps, if I want them to, can automatically become real-time applications, which is pretty cool.